So today, we're diving into a really cool discovery that basically rewrites the rulebook on a part of the brain we thought we had all figured out. It turns out this ancient piece of wiring that we all have, well, it's been doing a lot more than just the simple stuff. Let's get into it.
Have you ever caught yourself doing this? Somebody asks you a question like, hey, what'd you have for dinner last Tuesday? And without even thinking, your eyes just kind of drift up towards the ceiling. It's this weirdly universal thing we all do. And as it turns out, the reason why might be hiding in a part of our brain that we've been totally underestimating.
Okay, so to really get why this new discovery is such a big deal, we first have to talk about the part of the brain at the center of this whole story, the superior colliculus. For decades, scientists had a very clear, and honestly, a kind of boring idea of what this thing was for.
The thing about the superior colliculus, or SC for short, is that it is old, like evolutionarily ancient. This isn't some new fancy part of the brain that only humans have. Every animal with a backbone, from a fish to a lizard to you, has one. It's a really fundamental piece of our brain's architecture.
And because it's so ancient, scientists figured its job must be pretty simple, right? The SC was always seen as the brain's main reflex center. You know, it's the part that makes you instantly whip your head around when you hear a loud bang. It's the autopilot that jerks your eyes toward a sudden flash of light. Basically, everyone thought it was just the brain's simple, hey, look over there, button. But what if that simple part of the brain was doing more? Researchers at the University of Chicago decided, hey, let's put this old theory to the test. They designed a really cool experiment to see if the SC was involved in something way more complex than just reflexes. They wanted to see if it was involved in abstract thought. And their experiment was pretty clever. They had people look at an image and then mentally categorize it. But, and this is the most important part, they had to keep their eyes perfectly still, locked on one spot. This was key because it was designed to take the SC's main job, moving the eyes, completely out of the equation. All that was left was the pure act of thinking. So, going in, the team expected to see a lot of activity in a more advanced part of the brain called the parietal cortex. I mean, that's a known hub for higher-level thinking, no surprise there. The real long shot, the big question they were asking was, would this ancient, simple reflex center even show up to the party? And this is where the story gets really, really good. Because what they found wasn't just some minor surprise. Nope. It was something that fundamentally challenged what we thought we knew about how the brain works. Okay, get this. The results were absolutely stunning. The superior colliculus wasn't just involved a little bit in the thinking task. It was a total superstar. Its activity was actually stronger and more critical for making the right call than the parietal cortex, you know, the very part of the brain everyone assumed was in charge. I mean, you can just feel the astonishment in the lead researcher's own words. Dr. David Freedman literally said this was a really surprising place to find these signals. That's kind of like a mechanic discovering that the turn signal in your car is also helping to calculate your gas mileage. It's just not where you'd expect to find it. All right, so the SC was buzzing with activity, but was it actually necessary for the task, or was it just kind of listening in on the conversation? To answer that, the scientists had to do something pretty decisive. They needed to see what would happen if they took the SC offline, just for a little bit. And the results were completely definitive. With the SC up and running, performance on the thinking task was great, high accuracy. But when they temporarily numbed it, whoa. Accuracy just plummeted. This was the smoking gun. The SE wasn't just involved, it was absolutely critical for this complex cognitive job. So let's just recap. A brain region we thought was only for reflexes is also a powerhouse for abstract thought. What in the world does that actually mean? Let's zoom out and connect this back to our everyday lives because this is where it gets really fascinating. This is the central mystery, right? The SC is the master of space. It's all about mapping the world around us. So why on earth would the brain use a spatial tool to solve a totally non-spatial abstract problem like sorting images into categories? Well, the answer might be something we do all the time without even realizing it. I mean, think about it. We look up into space to find a memory. When we're weighing a tough choice, some of us literally move our hands like we're using a scale. We talk about organizing our thoughts. We are constantly using space and physical actions to help us think. And this brings us to this just beautiful analogy from Dr. Freedman. He said it's like the brain is using the SC as a kind of mental graph paper. Sure, it can use that paper to plot out physical locations in the real world, But it can also use that exact same grid to map out abstract ideas, weighing them and organizing them in a conceptual space. So, the ultimate takeaway here is pretty profound. Our brain is incredibly efficient. It repurposes its powerful ancient spatial mapping tools to give our abstract thinking a special oomph. By putting ideas on this mental graph paper, we can handle them, sort them, and solve problems way more effectively. It's an amazing evolutionary hack. And that just leaves us with this one last fascinating thought. If the simple reflex center has been moonlighting as a cognitive engine this whole time, it really makes you wonder, doesn't it? What other simple parts of our brain, the ones we think we've got all figured out, are just hiding their own incredible undiscovered superpowers?